The last thing we're going to look at in this unit, now that we know how to draw the structures of compounds, now that we know how to name them, we're going to look at how to quote unquote weigh them. How do we assess the mass of a compound? And what we're going to do right now is kind of just look at a single molecule um, or a single atom. And then a little bit later, we're going to put it into much, much bigger perspective. But since, chemistry is the study of, matter, anything that has mass and take up space, we know that atoms of an element have a mass. We always measure them in units of atomic mass units. A little bit later, as I said, we'll kind of put that into more things that we're familiar with, like grams, and then the new concept called a mole, which allows us to look at a whole bunch of molecules all at once. But how do we weigh a compound? How do we weigh a molecule? This is where the periodic table is going to come in handy. So um, we have kind of used the periodic table to look at periodic trends. We can get information about how many protons they have, how many electrons they have if it's neutral. We've used the periodic table to like do electron configurations and help us out with that. But the periodic table also gives us ideas about how much an atom weighs. This number, it's typically at the bottom. So if we look at lithium here, that number right there tells us how much one atom of lithium weighs in terms of atomic mass. Now remember that number there is an average of all the isotopes. It's the average atomic mass. And so that's what we use when we're going to calculate how much one single atom of lithium weighs. And in this case, lithium would have a mass of 0.6941 atomic mass units. Now, if I look at chlorine on the other side here, chlorine's mass is 35.453 atomic mass units. Now, what if lithium and chlorine were to react and form lithium chloride? How much does one molecule of lithium chloride weigh? Well, we would take the mass of lithium, 6.941, add it to the mass of chlorine, 35.453, and that would give us 42.394 atomic mass units. So that's what we would say that's how much lithium chloride weighs. And as I said later, we're going to put this more into more tangible units of mass, like grams. So let's get a little bit of practice with this. And find what is the mass of this compound. This is methanol. So what we need to do is look at how many of each atom we have, and then look at the periodic table. So we have one carbon, and then there are a total of 4 hydrogens and 1 oxygen. So we look at the periodic table and we find the mass of carbon. So carbon is 12.011 atomic mass units. Hydrogen is 1.008 atomic mass units, but notice I have 4 of them. So I'm going to multiply that number by 4. And then oxygen has an atomic mass of 15.999 AMU. So before I add these all up, I'm just going to finalize this calculation. The mass all the hydrogens contribute is 4.032 atomic mass units. So now I'm going to add up this number, this number, this number, put it all together. And that comes out to 32.042 atomic mass units. All right, let's look at one more, kind of a little bit more of a complicated problem because this is going to incorporate something that we just covered. What is the mass of calcium nitrate? And you look at that and say, well, what's the formula? And I'm going to tell you, you need to figure it out. You know how to do this now. You know how to name or how to take names and go to formulas. Okay, so let's break it down. This is ionic compound. So what is calcium? So I look up calcium on the periodic table. And when it is in an ionic compound, what charge does calcium always have? 2 plus. Now, what is nitrate? Nitrate is one of those polyatomic ions that you need to have memorized. NO3 minus 1. Now, this compound is neutral, so the charges have to add up to 0. What do I need to do this, if anything? Do I need to add more calciums? Do I need to add more nitrates? What do I need to do in order to make the charges balance out? So if calcium is plus 2 and nitrate is minus 1, I need 2 nitrates to balance that charge out, to make it 0. Now, let me kind of draw this out so you don't miss this. What we're saying is that for every calcium ion, we're going to have 2 nitrates to balance that out. So when you look at the formula for this compound, and then you need to know how much, what is the mass of it? There is 1 calcium. How many nitrogens are there? Well, if I take this subscript and I put it into here, I have 2 nitrogens. I can look at this other structure over here and see that, oh yeah, there's 2 nitrogens total. So 2 nitrogens. How many oxygens do I have total? Well, if I take this subscript and I put it into here to these oxygens, 1 nitrate supplies 3. So 2 nitrates will supply a total of 6 oxygens. You can get this really quickly by just doing 3 times 2. But you can also look on the other side here. This nitrate has 3. This nitrate has 3. So that's a total of 6 oxygens. All right, now I'm just going to look the masses up on the periodic table. So calcium is 40.078 atomic mass units. Nitrogen is 14.007, but I'm going to multiply it by 2. And then oxygen is 15.999. I'm going to multiply that by 6 because I have 6 of them. And then let's just do a little bit of preliminary math before we add it up. So add up all of the nitrogens and add up all of the oxygens. And now I'm going to add up these 3 numbers. So 40.078 atomic mass units plus 28.014 AMU, 95.994 AMU. And one of the things I do want to highlight is it's elementary right now, but do keep track of your units, because that's going to help you with much more complicated calculations down the road. Units can kind of tell you if your calculations are set up correctly. So I add all of that up, and that comes out to 164.086 AMU. And as I said earlier, we're going to expand on this concept because right now we're talking about just one molecule or one atom. Very rarely, and in fact, you probably will never ever deal with just a single atom or a single molecule. When we do chemical reactions in lab, we're dealing with millions upon millions upon millions upon millions of molecules all at once. And so we have a type of unit or a measure that we can deal with all of those numerous atoms and compounds all at once. And that's something we'll get to a little bit later.